David Ken here with another IB question in topic 4.2. We're looking at traveling waves, and we have two graphs. Graph 1 shows the variation with time of the displacement of a particle, and graph 2 shows the variation with distance of the same particle. And so we see two waveforms on two graphs. One of them is like a photograph of the wave at a particular time, and the other is a record of the heights of the waves over changing times. And they both have the same shape, but they mean different things. We want to try and use these two graphs to respond to a couple of different questions. First, we're asked to state what is meant by a traveling wave. The key feature of traveling waves is that traveling waves are waves that transfer energy. This is in opposition to standing waves, which don't transfer energy. And as a side note, neither traveling waves nor standing waves transfer material, transfer matter. The medium does not go from place to place in any case. It's just whether or not energy is transferred from place to place. Part 2 says to use the graphs to find a couple of different things. We're looking for the amplitude, wavelength, frequency, and speed of the waves. So we'll start with the amplitude, pretty straightforward. The amplitude is the maximum height of the wave, but on which graph? Well, actually it doesn't matter, because both graphs are a record of the same wave. One is in a time domain, one is in a length domain, but both have the height of the wave in time and with distance. So we can read the maximum height from either graph and get the same answer. And the answer looks like it's going to be 4 millimeters. Next, we want the wavelength of the wave. We have to think, okay, which graph? The wavelength is the length of the wave. How long is one copy of the wave? And this would be in the distance domain, not in the time domain. The time domain would give us something different. It would give us the period. The wavelength is how long one copy of the wave is from start to end of that copy. And we see that it's 2.4 centimeters. Next, we want the frequency. The frequency is not something that we can read off the graph directly, but it does come from graph 1 in the time domain, because we know that frequency is equal to 1 divided by the period. So we just need to find that period. The period is the amount of time that it takes for one copy of motion to occur, so that's all the way out to here. We go up and down and back in 0.3 seconds. Divide 1 by 0.3 and we get 3.3 per second. You could also say 3.3 hertz. Either answer is perfectly fine. Finally, we want the speed. We don't need the graph anymore. I think we have everything we need, because wave speed is wavelength times frequency. And we just took measurements of those two things. That's 2.4 centimeters times 3.3 per second. And that gives us a total of 8 centimeters per second. You could also say 8 times 10 to the negative 2 meters per second. Again, either answer is appropriate.